Okay, guys, so in this video, I will explain a few of the questions and for you guys and how does these questions work. So in particular, the drawing questions is basically exactly the same as what I've drawn in the notes. So, and I have it in the book and also I've drawn it in the last video for you guys, so you guys can just use that, okay? But in particular, I want to talk about some of the questions in the book. So it should be, on the booklet it says year 12 wave question sheet, so it didn't really give you a number, so just have a look. And the ones that we are doing for this topic is changing wave speed. Okay, so we're gonna have a look over a few questions, and then some of the questions you can just try it yourself, okay? All right, so the first question I'm gonna talk about is question 2. Okay, so let's have a look at question 2 and how we will solve this question. It says a wave is generated in deep water by a sound source vibrating with a period of t. Okay, so I know period t equal to 0.54 seconds. Okay, and then the wavelength of the wave lambda equals to 1.7 meter. It travels into shallow water where wavelengths become, okay, then I'll call this wave 1. Wave 2 is going to equal to 1.2 meter. Say this is deep water and this is shallow. Okay, so use F equals 1 over T, calculate the frequency deep water. So this one is, they've already give you the equation, so you can just use the equation. You don't even need to go pick equation, okay? So, but the equations we have is I'll write over here. T equals 1 over F, V equals to F lambda, and we have N1 sine theta 1 equal to N2 sine theta 2. V1 over V2 equals to lambda 1 over lambda 2 equals to N2 over N1 equals to sine theta 1 divided by sine theta 2. These are for all of the equations that we have over here, okay? Later we can go in there and pick, okay? So A is easy, just 1 over, just F equals to 1 over T equals to 1 over 0.54, okay? Let me put that in the calculator. 1 divided 0.54, okay, that gave me 1.85. Frequency unit is hertz. Okay, all right, so next one. And B, what is the frequency in shallow water? Frequency will stay the same. So frequency will equal to 1.85 hertz as well. So as I've explained, when wave traveling from one to another medium, the frequency don't change, okay? All right, see, so then use V equals F lambda to calculate speed in deep water. Okay, so C V equals to F lambda. So now this is V2. Hold on, in deep water or shallow water? C, in deep water. Deep water is this one. Okay, so that's V1. V1 equals lambda 1. So 1.85 times deep water 1.7. Okay. Okay, why don't I say this is deep? This is going to be shallow. S. Okay. And then I can change this is deep speed and then deep wavelength. Okay. All right. So that's easier for me to do just so I don't get it wrong. Okay. All right. So time 1.7. Bend 3.15 meter per second. All right, question D. Use V equal d divided by t, calculate the distance the wave will travel in deep water in 5.8 seconds. Okay, V equal distance divided by time. That's a bit of a strange question. It's a mechanics question. Well, yeah, whatever they ask us. Okay. So now speed, we know 3.15 equals to distance, that's what it's asking, divided by time, it gives us this 5.8 seconds. Okay, I guess distance will equal to 3.15 times 5.8. Okay, so put that in the calculator. 18.3 meter. Okay, all right, last question, E. Calculate the speed in shallow water. Okay, so V shallow V shallow water, V equals F lambda, same thing. Lambda now is going to be shallow water. So we're using this equation. Okay, and then we put it in there, frequency, 1.85 hertz times shallow water, 1.2. Okay, put in the calculator. 22 meter per second. Oh, hold on. 1.85 times 1.2, 2.2 meter per second. Okay, all right. So that's question 2 over there. Okay, now let's have a look of question 3. Question 3, use a refractive index for diamond. Okay, I say N diamond equal to 2.4, N glass equal to 1.5. Then speed of light in air, So V air in air equal to 3.0 times 10 to the power 8 meter per second. First one, A. What is the refractive index of air? So this one, it should normally be given to you, but we mentioned it a few times. The refractive index of air is the same as the refractive index of a vacuum, and that is our benchmark for determining what is the refractive index. So that's just 1.00. Okay, and there's no units because it's a ratio. Okay, all right. So now question B. Use NdVd NAVA to calculate the speed of light in a diamond. Okay, so that is this equation over here. Obviously, the equation is going to be given to you. They were given to you like this: V1 over V2 equals to N2 over N1. Okay, actually, we're given to you like this. Okay, so you go, well, V air times N air is going to equal to V diamond multiplies N diamond. And which one is 1, which one is 2, does not matter. So you just put it in there. Okay, so now I'm going to put the numbers in. All right, V air is 3 times 10 to the power 8 times 1, going to equal to V diamond times N diamond, 2.4. Okay, so now V diamond, 3 times 10 to the power 8 divided by 2.4. Okay, so put that in the calculator. (1.25 times 10 to the power 8 meter per second). Okay, all right, so that's number question 3. And then now calculate the speed of light in glass. So I'm gonna still using the same method. Speed of light in glass, say glass over here. Okay, still same. Okay, V1 over V2 equals to N2 over N1. So now let's have V air and air equals to V glass times N glass. Okay, so now put the numbers in. 3 times 10 to the power 8 times 1 equals to V glass. We don't know. Asking V glass. Okay, and times N glass. So N glass is 1.5. So V glass will equal to 3 times 10 to the power 8 divided by 1.5 equals 2.0 times 10 to the power 8 meter per second. Okay, so same question as this question. Okay, question D. Okay. All right, let me have a look at all the other ones. Oh yeah, it looks like all the other questions are exactly the same. Okay, so I think you guys can have a try. If you experience any problems, then you can let me know. Okay, they're basically just like this. Same. Equation 1, 2, 3, 4, and then put it in the calculator. Okay. All right. So any questions, send me an email and I'll make another video for you guys if you got get confused. Okay. All right. Have a good day, guys. See you in the next video.